This final video on Hess cycles, we're looking at the enthalpy change calculations using enthalpy of formation data. This is a different calculation to using enthalpy of combustion data. So you've got to be very clear when you're looking at the table of data just what information you have got. So we know this is enthalpy of formation data because it has got this subscript F here. So, just as we said previously, regardless of the route taken, the difference in the enthalpies between the starting point and the finishing point will be the same. So, in this case, we're trying to compare the different stuff. Trying to compare this arrow here going from elements to the products and this purple line here. We're starting from the elements, going all the way to the reactants, and then following this neutralization reaction. So as we've said, the products is equal, the enthalpy of formation of the products, change of formation of the products, is equal to the enthalpy change of formation of the reactants plus the enthalpy change for this reaction. The subscript here is showing the reaction. Or, as drawn, the red arrow equals the purple arrow. And just to check this, so if I just remove these arrows, you can see that on the left hand side we've got one sodium atom, one oxygen, two hydrogens, one chlorine. On the right hand side, one sodium, one oxygen, two hydrogens, one chlorine. So this means that they have been formed from the elements. Now, so we've got the enthalpy of formation of sodium hydroxide from sodium, half a mole of oxygen and hydrogen, along with enthalpy of formation of hydrogen chloride or hydrochloric acid, and from hydrogen and chlorine. And the same elements make these two products here. So now we've got our arrows back, and we can see that, just to remind ourselves, that the red arrow equals the purple arrow, and this is states that the sum of the enthalpy change of formation of the products is equal to the sum of the enthalpy change of formation of the reactants plus the enthalpy change of this reaction here. This equation is no good to us because we're really interested in the enthalpy change here of this reaction, or just to generalize it, enthalpy change then is equal to the sum of the enthalpy change of formation of the products minus the enthalpy change of formation of the reactants. The only way I remember this is I say to myself, using the enthalpy of formation data, it's not R minus P. It's not CR minus P, but it's FP minus R. And again, if you can think of a nice way to remember that, then please let me know. So let's have a look at a worked out example here. So what we've got is the reaction between ethane and oxygen, or the combustion of ethane to make carbon dioxide and water. Both ethane and oxygen come from the elements carbon, hydrogen and oxygen, and likewise the products carbon dioxide and hydrogen. Fully balanced equation, and so down here at the bottom we have got carbon, which goes, and hydrogen, which goes to make ethane, oxygen, which provides oxygen, then carbon and oxygen to form carbon dioxide, hydrogen and oxygen to form water. What you can see here from the table of data given for this enthalpy of formation data is we've got the enthalpy of formation for ethane, enthalpy of formation for carbon dioxide, enthalpy of formation for water. There is no enthalpy of formation for oxygen, and this is because the enthalpy of formation for elements is defined as 0 kilojoules per mole. And it's logical because enthalpy, because we're looking for enthalpy change, and if you're starting from 1 mole of an element, so if you're making 1 mole of a substance from its constituent elements, well, oxygen is already provided as oxygen, so there is no change occurring, and so there's no enthalpy change occurring. So we need to factor that in when we're doing our calculation. So remember that the enthalpy change using enthalpy formation data is given by the sum of the enthalpy change of the products minus the enthalpy change of the reactants. So in this example above, the enthalpy change of the products, well, we've got 2 lots of carbon dioxide, 2 times minus 394. We've got 3 molecules of water, that's 3 times minus 286, which gives us a grand total of minus 1646. And we're going to subtract away from that the value for ethane, which is minus 84.7. There's only 1 molecule here, so we don't need to multiply. And that will give you a value of 1561.3 kilojoules per mole. Again, as with the enthalpy of combustion data, in this reaction, whenever you're doing these types of calculations, always quote this formula first of all. That itself is usually worth 1 mark. Okay, so that is the enthalpy of formation. That is how to do a calculation using enthalpy of formation data. It might be a good time now to go back and revisit the video on enthalpy of combustion data, just so that you can compare and get it straight in your head the difference between the two calculations. Okay. Thank you for watching.